Hi children, good morning. Welcome back to our session. Our topic is light, reflection and refraction. So in the last class, we have learned how to draw the ray diagrams regarding the convex lens and the concave lens. And today's our topic is about the sign convention for spherical lenses. Already we have learned in the mirrors, sign convention in the mirrors. Now we are going to learn about the sign convention of the spherical lenses. Let me see. For lenses we follow the sign convention similar to one used for spherical mirrors. All measurements are taken from the optical center of the lens which lies on the origin of X and Y axis. Already we have known about our mirrors. If you go for the lenses, so here the X axis and also the as well as Y axis we are going to take from the optical center. So this is called as the optical center. According to the convention of focal length of a convex lens will be the positive and the concave lens will be the negative. Now let me go for the lens formula and the magnification. Next, let me go for the lens formula and magnification. So according to the lens formula, object distance is U, image distance V, focal length F. Then what's the lens formula? 1 by F is equal to 1 by V minus 1 by U. It's very important, children. 1 by F is equal to 1 by V minus 1 by U. This is the lens formula. Next, let me go for the magnification. Magnification is defined as the ratio of the height of the image, and the height of the object. So magnification is denoted by the letter small m. Magnification is denoted by the letter small m. So m is equal to height of the image. Height of the image is h dash by height of the object. Height of the object is h. So finally m is equal to h dash by h. That is equal to v by u. What is v? Here it is the image distance by object distance. So what is the formula for the magnification? H dash by h. That is equal to v by u. Okay? Understood, children? This is all you have to copy to your running notes. Then regarding this, let me solve problem. Okay? Are you ready? Let me see the problem.
Now we've been studying properties of images formed by the spherical lenses. Take a moment and go through the properties. One of the properties of an image is its position in space. From these tables, we see that the position of the image changes as the object's position changes. There is an equation or formula which gives us the relation between the objects and the image's position. And that formula is what we call the lens equation. Let me just write down this equation first. This is the lens equation. 1 over f is equal to 1 over v minus 1 over u. In this equation, there are three unknown quantities. U represents the object's distance from the lens, V represents image distance from the lens, and F is the focal length. To understand this, let's consider a case for a convex lens where object is kept beyond 2f1. What will be F here? It is the distance between the optical center O and the principal focus of the lens. This distance will be equal to F, and this distance will be U, and this will be V. This lens equation is valid for all spherical lenses as well as for any position of the object. However, we can't use this equation directly. There are some sign conventions that we must follow before using it. And what are those conventions? We follow the Cartesian sign conventions. Do you remember the Cartesian sign conventions we'd seen for spherical mirrors? Here they are. The object is always placed to the left of the mirror. Distances are always measured from the pole. Distances to the right are positive and to the left are negative. And distances above the principal axis are positive and below it are negative. The concept is similar for lenses. For our lens, we assume the optical center to be the origin. So the first convention we follow is that we always keep our object to the left of the origin or the optical center. Can you guess the second convention? Second convention that we follow is that we measure all the distances from the optical center. For instance, if we take this point on an object, then the distance of this point from the lens is measured from the optical center of the lens like this. The third and the fourth conventions are easy. Here they are. I'm sure they're self-explanatory. What is that we measure above and below the principal axis? Yes, the heights of the object and the image. And what do we measure to the right and the left of the optical center? Yes, the positions of the object and the image. But according to the first sign convention, the object is always kept to the left of the optical center. This means that the object's distance from the lens will always be negative. But the image distance could be positive or negative depending on its position. What about the focal length? Well, the focal length can be measured on both sides of the lens, right? Isn't it the same on both the sides? Which is why there is a fifth rule that tells us the sign convention for the focal length of a lens. For a convex lens, focal length is considered to be positive and it's considered to be negative for a concave lens. So these were the 5 sign conventions that are used for the lens equation.
Let me solve the problem. So here is your problem. A concave lens. What lens we are taking, children? It is the concave lens. Has the focal length of 15 centimeters. What is the focal length? 15 centimeters. At what distance should the object from the lens be placed so that it forms an image at 10 centimeters from the lens? Also find the magnification produced by the lens. This is our problem. Let me solve. Yes. So before going to solve, a concave lens always form a virtual erect image on the same side of the object. This one we have to know. Okay. Next, let me write what it has given for us. What it has given, children? Focal length is given for us. So focal length of a concave lens. Focal length, or concave means we have to take it as the negative. So for focal length, f is equal to minus 15 centimeters. Then so that it forms an image at 10 centimeters. Image is nothing but V. Image distance V is equal to minus 10 centimeters. What we have to find? We have to find what distance should the object from the lens we have to place it. That means we have to find the object distance. Object distance u is equal to question mark. We know the lens formula. What is that? 1 by f is equal to 1 by v minus 1 by u. We want 1 by u is equal to 1 by v minus 1 by f. Just substitute the values. 1 by u is equal to 1 by minus 10 minus of 1 by minus 15. So this it will become minus 10 plus 1 by 15. So take the LCM for 10 and 15. We are going to get it as 30. So 30 is the LCM. So minus 3 plus 2. Minus 3 plus 2. So that is nothing but minus 1 by 30. So u is equal to minus 30 centimeters. How much we got the u now? Minus 30 centimeters. What is this? This is the object distance. Object distance u is equal to minus 30 centimeters. That's all children? Finished? No. Still what we have to find? Also find the magnification. Also we have to find the magnification. What is the formula for the magnification? Already we know that M is equal to H dash by H, that is equal to V by U. Here we are not having the H dash by H. So we are having the V by U. So M is equal to V by U. What's the V value? Minus 10 centimeters by, now we got the U value, minus 30. So that is equal to, minus minus will get cancelled, 0 0 will cancel, 1 by 3. What is the value of 1 by 3? Is nothing but 0.33. What is that? 0.33. So it is the positive sign. We got the positive, not the negative. Positive shows that the image is erected vertical. So this is 1/3 of the image will be the 1/3 of what we have taken the object. Understood? Once again. So it has given the focal length as f is equal to minus 50, image distance d is equal to minus 10 centimeters, object distance u is equal to, we have to find. So formula 1 by f is equal to 1 by v minus 1 by u. We want 1 by u, so 1 by v minus 1 by f, that is nothing but if you substitute the values, we are going to get it as minus 1 by 30. So u 1 by u is equal to minus 1 by 30 means u is equal to minus 30 centimeters. What is this? It's the object distance. Then we have to find the magnification. Magnification m is equal to v by u. Substitute the values. So both are minus, will get cancelled, will get as the positive. So the image distance, the image will be 1 by 3rd what we have taken the object. Okay? Understood now? Yes. So this is about our magnification, lens, formula and the magnification. Regarding this we have solved the problem. And next let me go for the next topic is power of the lens. Okay children? Carry on. Next let me go for power of the lens. The degree of convergence, or what do you mean by convergence children? It is going to meet at a point. Or divergence. What do you mean by divergence? It is going to divide it. So the degree of convergence or divergence of light rays achieved by a lens is expressed in the terms of power. It's very important for your 1 mark children. Define the power of the lens means the degree of, define the power of the lens means here. The power of the lens is defined as the reciprocal of its focal length. What's that? Reciprocal of the focal length. In the mathematics we will learn how to write the reciprocal. Reciprocal of A is equal to 1 by A. Reciprocal of 1 by P is equal to P. Is it? So here also the power of the lens is defined as the reciprocal of its focal length. So it is represented by the letter P. So P is equal to 1 by F. P is equal to 1 by F. Power of the lens is equal to, it's the reciprocal of its focal length. Then what are the units for this? The SI unit of the power of the lens is dioptry. What is that? D-I-O-P-T-R-E. Dioptry. It is denoted by the letter capital D. What's that? It is denoted by the letter capital D. 1 dioptry is equal to 1 by M. 1 dioptry is equal to 1 by M. So this power of the lens for the convex will be the positive. For the convex, positive, and for the concave it will be the negative. For the power of the lens, for the convex lens will be the positive and for the concave lens will be the negative. So regarding this, let me see a small problem. Okay? Yeah, here is your problem. Find the power of a concave lens of focal length. It has given 2 meters. Focal length is 2 meters. Let me solve, children. So what it has given for us? Focal length. Focal length f is equal to 2 meters. But concave lens means we have to take it as negative. Minus 2 meters. What we have to find? Power of a concave lens is equal to question mark. What's the formula? P is equal to 1 by f. So P is equal to 1 by minus 2. That is nothing but how much will get, children? Minus 0.5. So power of a concave lens is equal to minus 0.5 D. What do you mean by D? Dioptry. The units for the power of the lens is nothing but dioptry. Understood? Yes. By this, let me end up the session. I will show a small video regarding this. Watch the video and let me end up this today's session. Okay? By this, we have completed our light, reflection and diffraction chapter. Okay? If any doubts are there regarding this, we can clarify. Okay? Bye, children. I will copy down this one.
Of the lens. The ability of a lens to converge or diverge light rays depends on its focal length. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of the power of the lens. A lens having a large focal length deviates the rays less, while a lens having a short focal length deviates the rays more. Thus, power of a lens is defined as the reciprocal of its focal length in meters. That is, power of lens is equal to 1 upon focal length. The SI unit of the power of a lens is diopter, represented by D. If the focal length of a lens is 1 meter, then the power of the lens is 1 diopter. Example: calculate the focal length of a corrective lens that has a power of plus 2.5 diopter. Power of lens equals to plus 2.5 diopter. To calculate the focal length, we use the formula. P is equal to 1 upon F, or focal length.
Sign conventions for the lenses. The sign convention for lenses are same as those for the spherical mirrors, except all the distances are measured from the optical center. Distance to the right of the origin, that is positive for the x-axis, will be the positive, while that its left, that is negative for x-axis, is the negative. Distances above the principal axis, positive for the y-axis or positive, while those below it negative, y-axis or the negative. So what's the lens formula and magnification? Lens formula is 1 by V minus 1 by U is equal to 1 by F, or you can write it as 1 by F is equal to 1 by V minus 1 by U. Then magnification is denoted by the letter small m, height of the image by height of the object, that is h dash by h. Also we can write m is equal to h dash by h, that is nothing but V by U, whereas U means object distance and V is the image distance. Power of a lens. The power of a lens is the reciprocal of its focal length. That is P is equal to 1 by F. SI unit of power of lens is called as the diopter. It is denoted by the letter